Hello, my name is Aya Gamudi, and along with my friend, my colleague Shaima Nabil, we are going to present our topic about humor detection. Our problem is a binary classification problem where the input is a short text composed of few sentences, and the output is going to classify whether the input is humorous or not. And this is an example of the input-output, and here we can see the output is true or false. Our data preprocessing process was as follows. We first started by tokenization, where the text input is transformed into sequences of numbers, and then followed by padding to ensure that all sequences of each row are of the same length. And then we computed the vocabulary size, which is dynamically calculated based on unique words on the dataset. The original model from literature was as follows. At first, it was iterating on sentence level and row level, and then these sentences were sent to BERT embedding layer, and then with the parallel hidden layers, and then followed by computation layer, and finally the final layer to classify. The maximum sentences per row were 5, and the maximum sentence length was 20, thus the maximum row length was 100. The total parameters of the baseline was 110 million, which is the same number for trainable parameters, and the non-trainable parameters were 0, which led to the final accuracy, which is 98%. This is the training process for the baseline model. And we faced some problems with the baseline model. First of all, the model is a transformer-based model. It used BERT, leading to the high accuracy that it reached. But it has several issues, mainly the code accessibility. At first, the baseline code wasn't available, and we had it after multiple requests from the author itself. And then when it was downloaded, it was not coherent. The performance achieved maximum accuracy in the first epoch, but then starting from the second epoch, it started declining. The complexity and training time. The baseline had a complexity constraint. As for the training, training one epoch took approximately 3 hours. This is the training and validation accuracy over epochs and the training and validation loss over epochs for the baseline model. The milestone 1 and 2 overview. For the milestone 1, the changes were that we changed the embedding approach, but we used the word2vec instead of BERT embeddings to reduce model complexity, and we did the contextual modeling with YLSTMs. As for the milestone 2, we added a self-attention layer, giving the model greater flexibility to understand complex relationships in the text, and we tried different attention mechanisms. And as for the final work, for the final model, we used compared between multi-head attention and self-attention model. That's multi-head attention. It has embedding and BiLSTM, and then multi-head attention over the BiLSTM, and then sigmoid classifier if it's humorous or not. And that's the training for multi-head attention. That's the training and validation loss, and that training and validation accuracy. That's for self-attention model. That's our final model that we proposed. It has firstly the embedding BiLSTM and then self-attention layer, because self-attention model got higher accuracy than multi-head attention model during training and testing, and that's the graphs for self-attention model. That's the graph for loss and the graph for accuracy. Final model explainability. So we added we tried to visualize the attention weights to know where in the text is humorous or not, and we achieved this by having two models in the same model, but one retrieves the attention weights and one is trained on the original data. And we actually, after training the first model, we set the same weights to the second model, so we can retrieve the attention weights without training. That's an example for a humorous text. And the part that is humorous is Australian and has higher attention weight. And that's example for non-humorous text, and it detects some parts of the text as humorous by having higher attention weight. Thus testing sample and testing accuracy for our proposed model. For the final results, final model has higher accuracy than the milestone 1 and 2, but doesn't have higher accuracy than baseline, because the baseline is state of the art, and we cannot outperform perform it using this trainable parameter. So we try to enhance accuracy as much as we can by having also lower trainable parameter than the baseline, and we got higher F1 score than -1 and 2 and 2. Conclusion and future work. So we basically were able to classify if the text is humorous or not with accuracy for training 94, and we found interesting results such as it has higher attention weight if it's like Netflix or emoji or any port that can be used in joke, and we gained valuable insights throughout the course. For future work, we can extend this work by having how the text is humorous and check the dataset humorous intensity. Contribution for me and my colleague, references, and then demo time. That's a text, and it's false with probability 0.001, and that's the correct label. So it's protected as false. And that's a statement that is not false and also protected as not false. Thank you for listening for our presentation for today. I hope you enjoyed.